So in this example, we're supposed to find the area enclosed by these curves. I'm going to have to figure out what these graphs are. Y equals square root of x plus 4. Well, it's the square root. It's just the y equals the square root of x graph up 4. I know, of course, if I put in some values here, I can put in 0, 1, and 4, for instance. Square root of 0 is 0, 0 plus 4 is 4. Square root of 1 is 1, 1 plus 4 is 5. Square root of 4 is 2, 2 plus 4 is 6. So we get 0, 4, we get 1, 5, we get 4, 6. We would actually get 9, 7 if we plugged in here. Square root of 9 is 3, 3 plus 4 is 7. So 9, 7 would be over here about, somewhere like that. So that's my square root graph. The other graph here then, y equals negative x plus 4, that's pretty easy. That's just a line. It has a y-intercept of 4 and a slope of negative 1. So down 1 and over 1. It starts here at 4, goes down 1 and over 1. So that would be that line. And now the problem, of course, is if that's all that was given, that doesn't define a region, right? There's no area there. But then I'm told x equals 4. So x equals 4 is here. So if I'm talking about the area enclosed by this, by these curves, it would have to be this sort of triangular region here in the middle. Now, I have a choice. I can either set up rectangles that go vertically or rectangles that go horizontally. Now, we're going to want to do vertical here, but why? If I did horizontal rectangles, one rectangle might look like this, and that's fine. The right endpoint is 4. The left endpoint is on the red curve, which would be the square root of x plus 4. The problem is, if I come down here, the rectangle now has a different left endpoint. Now I could do that, but when I set up this integral then, I'd have to let my y-coordinates, the rectangles are moving in the y direction, right? The rectangles would start down here at y equals 0, and they'd have to go all the way up to here where they intersect, which looks like y equals 6. But here, in the middle at y equals 4, they'd have to switch. So I'd do one integral as y goes from 0 to 4. That's between the black and the blue graph. And then another integral from 4 to 6 between the black and the red graph. And I don't really want to do that if I can avoid it. So, can I avoid it? Well, if we let the rectangles go this way, vertically, then my top is always the red, my bottom is always the blue. And so I look at this, the length of the rectangle is a delta y. The top here is the red graph, which is square root of x plus 4, and the bottom is the blue graph, which is negative x plus 4. Now, I've said it looks like we know where they intersect, right? But we can find where they intersect if we set the y-coordinates equal to each other. So we would get square root of x plus 4 equals negative x plus 4. Well, then I would probably, to solve for this, I want to square both sides, but I want to get the square root by itself first. So I'd probably subtract 4 from both sides. So that would tell me square root of x equals negative x. Then I would square both sides. Negative x squared, negative times negative is positive. Subtract x from both sides and factor out an x. And oh, what am I doing? Forget that. It's been spazzing there a little bit. Okay, so let's go back to this picture. We know that they both go through the point 0.04, right? We've got that here. We've got the point 0.04 on the red graph, and we've got this 0.4 is the y-intercept of this graph, so we know they both go through the point 0.04. The square root of x plus 4 graph is going up like this. I guess what would happen when I was solving this and squaring both sides, that was making this into a full parabola, and that would be that this part here would come back around, and that's where I was getting x equals 0 and x equals 1. But that's not really a point of intersection because the square root graph doesn't curve back around. So I'm being a little silly here. What I need is to find this point. This point is definitely 0.4. We already found that. Okay, so this point here we know is 0.4. This point here is from where when x equals 4 and we solve this from this equation, and we already did that here when we plug in x equals 4 to this red equation, we get out y equals 6. So this is definitely the point 4, 6. So we don't have to solve anything here to find those points of intersection. And again, this point down here is just the point 4, 0. So to find this area, we want to march these rectangles across this region. My x-coordinates then start here at x equals 0. They end here at x equals 4. To find the area of one rectangle, I would take the top minus the bottom. The top is the y-coordinate. So I get square root of x plus 4. That's the top y-coordinate. And I subtract off the bottom y-coordinate, which is negative x plus 4. And then I multiply by the thickness of the rectangle, which is dx. So we get square root of x plus 4 minus a negative x, that becomes plus x, and then minus 4 dx. So square root of x is x to the 1/2. The 4's here cancel out. So I'm going to have to take 1/2 plus 1. So that's going to give me 3/2. Then I'm going to have to divide by 3/2. X to the 2, divide by 2, from 0 to 4. When I divide by a fraction, that's multiplying by the reciprocal. So 2/3 x to the 3/2 plus 1/2 x squared, evaluated from 0 to 4. So that'll be 2/3 times 4 to the 3/2 plus 1/2 times 4 squared minus 2/3 times 0 to the 3/2 plus 1/2 times 0 squared. Remember, with this 3/2 power, the 2 here then is my root. The 3 here is my power. So I get 2/3. The square root of 4 is 2. 2 cubed is 8. And all this is 0. So I get 16/3 plus 8 over 1. That's 16/3 plus 24 over 3, which would be 40 over 3.